welcome back to my chemistry class. Now I'm here to take energetics, and energetics consists of subtopics, which are enthalpy, entropy, and Gibbs free energy. I'm going to divide this class into two because of our time. And if I'm talking about what energetics, what is the meaning of what energy in the first place? Energy is the ability to do what? To do work. Now, energy in chemistry is kind of what complicated. There are some energy that we can't measure, while there are some that they are easily measured, e.g. heat energy. Okay, let me define enthalpy. What is the meaning of what enthalpy? Enthalpy is the total heat content of a system. Enthalpy is what? The total heat content of what? Of a system, accompanying either physical or chemical state. Now, if you're talking about total heat content of a system, it's subdivided into two. The useful, that means a fraction of the useful energy, is referred to as Gibbs free energy. Gibbs free energy. This is a fraction of that energy which does useful work. Now, the remaining part, which is due to the randomness of the system, is known as entropy. Entropy of what? Of the system. Now, let me now take it one by one. Let us talk about what? Enthalpy. Let us talk about enthalpy. We talk about what? Entropy. And we talk about what? Gibbs free energy. Now, let us take the first one, which is what? Enthalpy. As a state function, enthalpy, it is designated by capital letter what? H. Since it is a state function, this value is not important to a chemist. Only when a system changes from one state to another, when we have our delta H, which is known as change in enthalpy. All these parameters in chemistry, if they are measured in standard condition, we refer them as standard parameter. That is, e.g., when we measure our enthalpy in standard state, what is the meaning of a standard state in chemistry? That means our pressure of the system must be in 1 atmosphere. That means 1 atmospheric pressure. Our concentration of the system must be in 1 mole per dm³. The temperature of the system must be at 25 degrees Celsius. Why the material we are talking about must be in a stable physical state. Are you there with me? Yes. Now, if this parameter, which is change in enthalpy, it is measured in this standard condition, we donate it with delta H raised to power theta, which is known as standard change in enthalpy. If Gibbs free energy, which is donated with capital letter G, and the change in Gibbs free energy, which is delta G, is measured in standard state, it is given as delta G raised to power theta. The same thing with entropy, which is designated by capital letter S. Change in entropy is delta S. Standard change in entropy is delta S raised to power theta. Are you there? Yes. Good. Now, let us talk about enthalpy alone now. Enthalpy. Enthalpy is the total heat content of a system, either physical or chemical state. Now, if we're talking about enthalpy, I said it is designated by capital letter H, yes or no? Which this is not more important to chemists, but delta H is more important because of enthalpy is a state function. Are you there? Now, let us talk about change in enthalpy. Change in enthalpy, which is given as delta H. Okay, let me put it in standard. Now, what is the meaning of change in enthalpy? When a system moves from one state from what? Another. That means from initial state to what? To final state. We have what? Delta H. And if the system is in standard what? Condition, we call it what? Standard what? Change in what? Enthalpy. We have two types of what this. We have the number one, which is what? Exothermic. And number two, which is what? Endothermic. What is the system I'll be talking about? Is what? Is a reaction. So we call this what? Exothermic what? Reaction. And what? Endothermic what? Reaction. Now what is the meaning of what? Exothermic what? Reaction. Exothermic reaction is a type of what? Reaction which liberates its content to the what? Surrounding. I said what? Exothermic reaction is a type of what? Reaction which what? Liberates what? It to the what? Surrounding. Now it is given as what? Delta H raised to power what? Theta means what? Standard. Now if you want to write what? The value of what? Exothermic. We always what? Indicate what? Negative what? Sign. What is the meaning of what? That negative sign? It's telling us that what? Enthalpy of the initial state. Enthalpy of what? The initial state is lower than the enthalpy of the what? The final state, because the system has lost what? Energy to the what? Surrounding. I said this is what? A type of reaction that liberates what? Heat or energy to the what? Surrounding. Therefore, our delta H is always negative what? Sign. For what? Endothermic. Endothermic what? Reaction. Endothermic what? Reaction. Which absorb what? Heat from the surrounding. The delta H is given as what? Positive what? Sign. Since the what? Enthalpy of the what? Initial is greater than the enthalpy of the what? Final. Because energy is being absorbed from the what? Surrounding. Now, mathematically, change in enthalpy can be calculated as what? Delta H equals to summation of heat of what? Product minus summation of heat of what? Reactants. What is the meaning of this? I said change in enthalpy standard. It is measured as the what? Summation of heat of what? Product. That means final state minus what? Summation of heat of what? Reactant. That means initial what? State. Are you there? So now, if you are given what? Any question, this formula can be what? Useful to us. Let us go into what? Graph. Now, I can represent my what? Exothermic what? Reaction in form of what? Graph. I can represent the what? Endothermic what? Reaction in form of what? Graph. We call it what? Energy what? Profile. So if you have what? Energy profile for what? Exothermic, look at what I'm going to have. I'm going to have something like this. From here to here, this is what? My energy, delta what? H. From here to here, this is my what? Activation energy. This is my initial state, A plus what? B. Assuming that the ET2, or the what? Reaction we are talking about, we are having A plus what? B to form C plus what? D. This will be our product, which is C plus what? D. Now look at this what? ET2. This what? ET2 below here. This is what? The energy what? Profile. Now, in thermochemistry, if you want to write what? Any what? Chemical reaction, we normally write it alongside with the what? Heat produced. To indicate either the reaction is what? Exothermic or what? Endothermic what? Reaction. So I'm going to have what? Delta what? A standard for this equals to what? Now here, I'm writing what? This for what? Exothermic. Definitely my what? Delta H is what? Negative. And don't forget, I'm using what? This what? Formula to calculate change in what? Enthalpy of what? Of the system. Now look up. Look at what? This what? Energy profile for this what? Exothermic what? Reaction. We are having our initial state here, and we are having what? Our final what? State here. And the what? Formula says what? The summation of heat of what? Initial state, products, that means final state, minus what? Summation of what? initial state. So if I'm having something like this, my delta H from this what calculation will now give me what? I'm going to have what? What is this? This is my what? Product. You can see that this one is lower in energy. Let us assume that this place is what? 1, we have 0, we have 2, we have 3, we have what? 4. So I'm going to have what? 1, which is for my what? Product, final state. Minus what? What is my initial state? 2. What is my answer? Minus what? 1. What is the unit? The unit of what? Enthalpy is kilojoule per mole. It's measured in what? Kilojoule per what? Per mole. Now you can see the difference. That is always what? Negative. That is why when you want to write what? Exothermic what? Reaction, you must put the what? The negative sign. Are you there? And I said, when you're having what? Any equation in thermochemistry, we must put the what? It beside what? The reaction. Now, what is the meaning of what? This reaction? We call it what? Thermochemical what? Equation. Thermochemical what? Equation. Because it indicates the what? Heat of that what? Reaction. Are you there? Now, the energy profile for what? For the second one, which is for what? Endothermic what? Reaction. We're going to have what? Something like this. The initial is always what? Lower in energy than the what? Final. So I'm going to have what? A plus what? B. I'm going to have what? C plus what? D. So here I'm going to have what? Something like this. From here to here, that's my what? Delta what? H, which is equal to what? Positive. From here to here is called what? Activation energy. If this is my 0, I'm having 1, I'm having 2, 3. Now my delta H for what? This system is going to give me what? Final, which is what? 2 minus what? 1. What's the answer? That's what? Plus 1 kilojoule per what? Per mole. Are you there? Do you understand? Yes, sir. Any question? Okay. Let us move to what? Calculation in enthalpy. Calculation in enthalpy. Now, if you're talking about what calculation during what? Enthalpy. Calculation in enthalpy is based on what? Nernst's law. Because not all enthalpy are experimentally what? Determinable. You can't determine some enthalpy of a system. So we use what? Calculation to determine what? Enthalpy of a system. And the enthalpy of a system can be calculated using Nernst's law of heat of summation. What is the meaning of this law? The law states that what? Enthalpy of a system is the same. Either the system occurs in a step or in several steps. The heat of a system, which is enthalpy, is the same whether the system occurs in a step or in several steps. Now, in calculating what? Enthalpy of a system. Enthalpy of a system is always calculated based on the type of reaction we are talking about. We have combination reaction, we have what? Formation what? Reaction, we have what? Neutralization reaction, dissolution what? Reaction. Now, Nernst's law now. What is the meaning of what? Nernst's law? It says that what? If a system occurs in a step or several steps, the heat of that what? System will remain what? The same. Now, this is the meaning of what? Of that. When A plus what? B, we use it to form what? C plus what? D. Now, from this system, this is what? A single step what? System. Before forming what? C plus D, we can what? Go in another what? Rule. That means A plus what? B, we can use it to form what? E plus what? F. Are you there? After forming this E plus F, we can use it to form what? Z plus what? W or anything. Now, from this one, we can now form our what? C plus what? D. That is what it's saying. That means if we have what? Our delta H here, which is for what? For the reaction, we're going to have this. 1, I have what? This. 2, and I have another one. 3. So this will give me what? The summation of all of this 8. 1 plus what? Delta H what? 2 plus what? Delta H what? 3. Do you get it? So calculation. Example 1. Calculate the heat of formation of CO given the chemical reaction below. So I have the first reaction, which is what? C solid, that means carbon, and oxygen to form what? CO2. My delta H for this reaction is minus 393 kilojoule per mole. I also have my CO plus what? O2 half to give me CO2. Delta H for this is going to give me what? Minus 285 kilojoule what? Per mole. So the question asks us to calculate the heat of what? Formation of what? CO. Yes or no? Look at this simple question. How am I going to go about this simple question? The question says calculate the what? Heat of formation of what? CO. Given what? The chemical what? Reaction what? Below. Look at this what? Thermochemical what? Given for you. The first thing you are going to determine, write the word required equation. What is the required equation? Formation of what? CO. Are you there? Now let me what? Give you this hint. The formation of water, that means H2O plus what? O2 to give what? H2O. This is what? Let me assume that this is what? Liquid. Gas, gas. For this, I think my delta H equals to minus 286 kilojoule per mole. If you are forming 2 gas plus what? O2 gas to give me H2O gas, delta H what for this is minus 282 kilojoule per mole. Now look at this. From this what? Equation, I can say the formation, the heat of formation of what? Of water, which is liquid, is what? Minus 286 kilojoule per mole. Or the heat of combustion of hydrogen. Or the heat of combustion of hydrogen to form what? Water is what? Are you with me? So this is what I'm going to use here. That is the idea I'm going to what? Use here. For the formation of what? CO, I'm going to have what? Carbon, solid plus what? Oxygen, gas to give me what? CO. Yes or no? Delta H equals what? Unknown. Are you there? So if I have what? This is gas. If I have this, how can I what? Derive this equation from this what? Given thermochemical what? Equation. Now the first thing I'm going to look at is that I'm having my CO at the what? Product side. Yes or no? Now, where in this what equation do I have for CO, the equation 2? Yes or no? So I'm going to write solution. This is the required equation, yes or no? So let me reverse what? Equation what? 2. If you are reversing any thermochemical what? Equation, the sign is going to what? Change. When you reverse a what? Endothermic what? Reaction, it's going to turn to what? Exothermic. So I'm going to reverse for this. If I'm reversing, I'm going to have what? CO2 to give what? CO plus what? Half O2, gas, gas. What is my what? Heat of that reaction? It's going to give us what? Plus what? 285 kilojoule per mole. Since I'm reversing, I'm having what? Negative before. Here I will be having what? Positive. Do you get it? So I have what this. Let me bring what? This equation 1. Bring equation 1. So what I have in equation 1, I have what? C solid plus what? O2 gas to give me what? CO2. What's the delta H for that? Equals what? Minus 393 kilojoule what? Per mole. Now, I'm going to add the two equations together now. add the two equations together. If we are adding, everything at the what? Reactant side, we add it together, and everything at the product side, we add it together. So I'm having my CO2 plus what? C solid plus what? O2 gas to give me what? CO gas plus what? 1 over 2 O2 gas plus what? CO2 gas. Now, when you add what? Two thermochemical what equation together, we're going to add what? The heat of that what? Thermochemical what equation together. That means the heat of what? The reaction. So, for this, I'm going to have what? Delta H. I think it's going to give me what? Minus 10.8 kilojoule what? Per mole. When we are having what? This type of equation, since we are adding what? Two equations together, everything that appear in our reactant side, we're going to what? And also appear in our what? Product side, we're going to what? Remove them. Here we are having what? Oxygen. We are also having what? Oxygen here. We are having one oxygen here, and we are having what? Half. 1 minus half. What do I have? Because of what? Half. That one is what? Okay, we are having what? Half oxygen at this what? At this side. We are having what? CO2 here. Yes or no? CO2. We also have what? CO2 here. 1, 1. That's 0. So our resulting equation is going to give us what? C solid plus what? 1 over 2. Yes or no? You know how I get this half? 1 minus what? Half. So I'm going to have what? CO. Are you there? So what is the answer now? Delta H equals to give me what? Minus 10.8 kilojoule what? Per mole. Look at this what? Equation and look at this. Is it the same thing? When you balance all this, you're going to have what? 1 over 2. Yes or no? Yes. Is it the same thing or not? Yes. It's the same thing. That means what? Enthalpy for what? This is going to give us what? Minus 10.8 kilojoule what? Per mole. That is our answer. Calculate the heat of formation of propane. Calculate the heat of formation of propane. If the heat of combustion of propane is minus 2211 kilojoule per mole. If the heat of combustion of propane is what? Minus 2211 kilojoule per mole. Given the standard enthalpy change, of formation, this is how you're going to write it. Standard what? Enthalpy what? Change. That means formation of what? CO2, and for formation of what? Water is minus 393 kilojoule per mole and minus 286 kilojoule what? Per mole respectively. So now let us solve for this question now. The first thing you are going to do, what are you going to do? First of all, write the required what? Equation. What is the required equation now? We have what? Propane, which is what? C3H8, yes or no? When propane bursts in what? Oxygen, this is what we're going to have. CO2 plus what? H2O. Are you there? So let us balance what? The equation. We are having what? 3, 8, yes or no? 4. This is what? 8 plus what? 6. That's 6 plus what? 8. That's what? 14. Abi now? Yes. Bring it here. 14 divided by 2. What do you have? 14 divided by 2. That's 7. Look at that equation very well. Is it balanced? 2 times what? 3. That's what? 6. 2 times what? 4. That's what? Okay. We are balancing what? Oxygen, not hydrogen. So, note that 3 times what? 2. That's what? 6. Plus what? 4 oxygen. Yes or no? Equals what? 10 at this side. So, here what are you going to have? 5. 5 times 2, that's what? 10. Thank you. So, what is what? The thermochemical equation for this? Now, we don't know the heat of formation of what? Propane. That's a question. And we are given the heat of combustion of propane. You put C. give us what? Minus 2211 kilojoule what? Per mole. Thank you. So now, we know that our change in standard enthalpy equals to what? Summation of each of what? Product. Or final minus what? Summation of each of what? Initial. Or what? Reactant. I did. Now let me break it down. Let us look for what? Summation of each of what? Product now. Summation of each of what? Product is what? In our product side, what do we have? We are having what? CO2 plus what? 4H2O. Yes or no? So I'm going to write. Summation of heat of product is going to give me what? Heat of formation of CO2 plus heat of formation of what? H2O. How many of these are we having here? You put 3. How many of these are we having here? 4. From the question, we are giving what this? That's 3 times what? What is this? It's minus 389 what? 3 from the question plus what? 4 times what is this? From that question is minus 286 kilojoule per mole. Please help me to do this. I think I'm going to have what? Minus 2323 kilojoule per mole. This is for my what? Product, for my reactant. Summation of each of what? Reactant. We're going to have what? In my reactant side, what do I have? I have what? Heat of formation of C3H8 plus what? That is 5. Formation of what? O2. Now, let me what? Tell you this. When you're having elements, and it was standard what? State, or in stable what? State, the heat of formation for that what element is always equal to what? 0. For what? Oxygen, air, the heat of formation of oxygen is equal to what? To 0. So I'm going to have this in my reactant side. So is this given? No. So I'm going to have what? Something like this. Now let me apply what this formula. What is the heat of what? Combustion of propane given to you? We are having what? This. So let us put in the value. This is what? From this what? Formula. We are having what? Minus 2211 kilojoule what? Per mole. Yes or no? So what do we have here? Minus 2323 kilojoule what? Per mole. My reactant side, what do I have? Minus what? Delta H formation of what? Propane. So bring this to this side. I'm having minus 2211 kilojoule per mole plus 2323 what? 3. It's going to give me minus what? Delta H. Now, what's the answer to this? Minus 112 or 112. 11 what? 2 kilojoule what? Per mole. But don't forget, you're having what? Minus sign here. Multiply through by what? Minus sign. What am I having? I'm going to have what? My delta H formation of propane to equals to what? Minus 112 kilojoule per what? Per mole. That's my final answer. That means heat of formation of what? Propane is going to give me what? Minus 112. Don't forget, if you are having an element in a standard what? State, the heat of formation of that element is always equal to what? 0. So thank you for what? For listening.